Number 1, p plus 3 plus 8 equals 10. What value of p is the solution to the given equation? Okay, whenever we're solving algebraic expressions, we're trying to undo what's been done to our variable. In this case, our variable we're solving for is p. So what has been done to our variable? 3 was added to it, and then 8 was added to it, and we arrived at 10. So let's, didn't mean to undo that parentheses. Let's undo what's been done to p in reverse order. So first we have that plus 8. I want to undo that. I want to do the opposite of that. So I need to subtract 8 because subtracting is the opposite of adding. Now, because this is an equation, there is an equal. Anything I do on the left, I have to do on the right too to keep it equal and balanced. So subtracting 8, plus 8 minus 8 on the left, that 8 just disappears and I have that p plus 3 remaining. And on the right, I have 10 minus 8, which is 2. And now p plus 3, the opposite again of adding here is subtracting. So I'm going to subtract 3. I have to do it from both sides. And on the left, I get p, and on the right, 2 minus 3 is negative 1. And that is going to be my answer. And lo and behold, there it is, A, negative 1. A thing of note about the parentheses in this problem, sometimes, a lot of times, the parentheses will make a difference in an equation. In this particular case, because we have addition twice, those parentheses don't mean anything. They just don't. But only in this scenario because they are both addition. Also, if they were both multiplication, it wouldn't make a difference. Show you as an example, like if I were to have 3 numbers, I said 4 plus 3 plus 5, and I just added them together, 4 plus 3 plus 5, I would get 12. Well, what if I put parentheses and said, add that first? Well, now it's 7 plus 5. Well, that's 12. I said, oh, no, add that first. Okay, well, that's 8 plus 4. That's 12. It doesn't change anything. If they're all addition or they're all multiplication, it doesn't change anything. When they are different signs like this, different things combined, like here we have addition and multiplication. Oh, it changes things. Because just as is, order of operations says I should multiply first 3 times 15. 3 times 5 is 15. And then adding 4 would get me to 19. But what would happen if I did like that? Then I'm saying, according to order of operations, do the parentheses first. 4 plus 3 is 7 times 5 is 35. So again, yes, in this particular one, if anyone says, well, could I have just ignored the parentheses and like added those together? In this particular case, yes, I could have. P plus 3 plus 8 is 11. And then undoing what's been done to p, I subtract 11 from both sides. Still have p on the left. 10 minus 11 is negative 1. See, I still got negative 1. But again, don't think you can do that in every one that has parentheses. This particular one you just could because they are both pluses, both addition. Number 2. All right, let's look at this one plot up close. This question up close, and then we'll look at their answers. The scatter plot shows the relationship between 2 variables, x and y. Which of the following graphs shows the most appropriate model for the data? So the model is kind of like when you think of the line of best fit, something that represents how the data is going. Well, what would you think, without looking at the answers first, if I drew a straight line, is that an accurate representation of what's going on? You go, I don't know. Things are, if I just kind of draw a line trying to connect everything together, that looks like a more curve. That might be more of a better model. Let's look, though, at their options that they're giving us and see if we find one like, Okay, up here on the left, we have that straight line. And I don't really think that's a good fit because, look, we've got 6 points that are nowhere near it. Just these 2 beginning and ending points are on the line. So it's not really representing all this data and how it swings down and comes back up. This one over here is even more wildly off. None of the points are anywhere near our data. Everything's way off away from the line and everything is clearly going up, and this is showing descending. That's not a good model. C, okay, we get a curve going more, but still a lot of these are off. It feels like these could be closer to the line, or this line could be closer to these points. Finally, we have D. There we go. It is arching right through that data, and it feels like we could expect more data points, like the data point for 1, or 1 for 6, and things, to be closer to this line than in any of the other 3 options. So D is the most appropriate model for this. It is the closest to representing how the data is actually going. Number 3, k squared minus 53 equals 91. What is the positive solution to the given equation? Okay, so k squared minus 53 equals 91. We're trying to solve for k, so we want to undo what's been done to it. K has been squared, and then 53 was subtracted. So we're going to undo that in reverse order. So I'm going to undo that subtraction first, do the opposite of that, which is adding. And I need to do it to both sides to keep my equation equal, keep it balanced like a seesaw. So on the left, those negative 53, positive 53, adding and subtracting cancel out, and I just have k squared. And on the right, 91 plus 53 is 144. Now the opposite of squaring, the way we undo that is to take the square root of both sides. So the square root of k squared is k, and the square root of 144 is either positive or negative 12. Now, they told us they asked us, what is the positive solution to the given equation? So we want that positive 12, and that is D. Be careful for ones like this. They didn't try it on this one, which I'm frankly shocked that they didn't, but it is incredibly common on problems like this for them to give you the negative solution as well, counting on you not to notice that they asked for the positive, and you go, negative 12, that was one of my answers, circle it, done, moving on, and you've just got it wrong because they specifically asked for the positive solution, not the negative. Again, I'm shocked that the negative option is not there, but be on the lookout, it often will be. Number 4, during a portion of a flight, a small airplane's cruising speed varied between 150 miles per hour and 170 miles per hour. Which inequality best represents this situation, where S is the cruising speed in miles per hour during this portion of the flight? When they say best represents, that's a key that some of these probably are true. That these are going to be true, during this, but they want to know which one's the best representation. So let's look at the options here. We have first that the speed was less than or equal to 20. No, we were told it was between 150 and 170. So it was in the middle. It was between 150 and 170 the whole time. Which actually, if you're looking at our answers, you can go like, hey, well, there's only one that's between 150 and 170. But still, it's a good idea to look at all of our options. B, it says that the speed was less than 150 for the whole flight. Well, no, we know it was between 150 and 170, so it had to have been greater than 150 and less than 170 during that time. C, it says S was less than 170 the whole time. This is where the best part comes in. Best represents. Because S is less than or equal to 170 the whole time. That's true. It is true that S was less than or equal to 170 for the whole flight. But it also had that lower end cap of 150. So it was between those two. So D is our best option, that S was greater than or equal to 150, but also less than or equal to 170. Yeah, and I'm really shocked that they didn't try something strange like flipping it like that just to see if they could mess with you and get you to choose the wrong signs. That's something they like to do a lot. But yeah, anytime that there is a best represents, be on your guard, because it usually means, like in this one, that we've got another answer that technically could work as well, but it's not the best. So yes, again, this was less than 170 the whole time, but since we were given that lower range, like sort of the ending point of 150, that this, where it was between 150 and 170, is the best answer, D. All right, we're given a chart here. Number 5, an object was launched upward from a platform. This graph shown models the height above ground, y. Height above ground is going up and down here. It is in meters of the object x seconds after it was launched. Okay, so our time in seconds is here. For which of the following intervals of time was the height of the object increasing for the entire interval? Go away, Post-it. Okay. All right, so let's look at our graph here. Time in seconds. At 0 seconds, really doesn't like when I draw dots and it goes crazy. Stop it. There we go. Okay, so at 0 seconds, it was like around 8 meters off the ground. Dots. I can't handle dots. Of all the things you ask a whiteboard to do, you draw a dot and it's like, oh my God, I want to draw a dot. I digress. So, okay, so we're starting at 0 seconds. And then this object was launched upwards from the platform, which was about 8 meters high. And then at 1 second, it was up here at 24 meters. At 2 seconds, it was up here, up to like 28 meters. And then it starts coming back down. All right, so when was it increasing? Well, from 0 seconds to 2 seconds, it is increasing. And then after 2 seconds, it's going down. Now note the little keyword on this one is increasing for the entire interval, not part of the interval, not some of the time. So the intervals that they have given us here are from 0 to 2. You go, okay, well that looks like my answer from 0 to 2. That is when it's increasing that whole time. B is from 0 to 4. And that's where they're going to get some people, because in that interval, it is increasing, but then it's also decreasing. And they wanted to know the entire interval it's increasing. So 0 to 4 is out. Our next one that they give us, I always like to look at the other options, even when I think that we have our answer. It says from 2 to 3. Okay, so that would be right in there. Nope, that's decreasing there, 2 to 3. And then from 3 to 4, nope, it's also decreasing there. They absolutely could have given us an option from 0 to 1 or from 1 to 2. Because in both those cases, it is increasing for that entire interval. But nope, the only one from the options that they've given us is from x equals 0 to x equals 2 is when it is increasing for that entire interval. Number 6. How many yards are equivalent to 1,116 inches? And they're being nice, and they're telling us that 1 yard is equal to 36 inches. So when we have proportions, we can always solve them this same way. There's more than one way to do them, and you can just kind of look at this and go, oh, since it's 1 yard for 36 inches, I can just divide. That's straightforward. That's great if that makes sense to you. But I want to show you the proportional way, because you can use this for any unit conversion, no matter how simple or how complex. So I'm given on one side this proportion that 1 yard is equal to 36 inches. So I can set up this proportion. 1 yard is to 36 inches. They are the same. On the other side, I want to set up the unit conversion, the one I'm trying to solve for. So we were given how many inches. So we want inches to be at the same place. Here they're the denominator, so they're going to be the denominator over here too. 1,116 inches, and I don't know how many yards there are. Anytime we have a unit conversion, we set up these proportions, and then we cross multiply. So when we cross multiply, do first 36 inches times x yards. 36 times x is 36x. And the other way, I have 1 times 1,116. That's 1,116. So 36 times x equals 1,116. I want to undo what's been done to x. X is being multiplied by 36, so I want to divide by 36. And when I divide 1,116 by 36, I use my calculator and I get 31. So x is equal to 31, and we said x is how many yards? So my answer is 31. 31 yards are equivalent to 1,116 inches. Number 7, f of x equals 14 plus 4x. The function f represents the total cost in dollars of attending an arcade when x games are played. How many games can be played for a total cost of $58? Okay, so in our function, f of x equals 14 plus 4x, and we're told that this is the total cost, and X is the number of games played. So then they're saying how many games can be played for a total cost of 58. Since they've said 58 is our total cost, then we need to put the 58 right here because this is cost. And we're solving for how many games. Games is X, so the X remains, and then we need to solve for X. So undoing what's been done to X, X has been multiplied by 4, and then 14 was added to get 58. So let's undo that in reverse. First, let's get rid of that 14. 14 is being added, so let's subtract it. That's the opposite. We need to do that to both sides to keep it even. On the left, 58 minus 14 is 44. On the right, I still have that 4x left. It's 4 times x, and the opposite of multiplication is division. So I'm going to divide both sides by 4. 44 divided by 4 is 11, and on the right now, I just have x. So 11 games can be played for $58. That seems really expensive. $4 a turn. Wow. Okay. All right, so 11 is my answer for that. F of x equals x plus b. For the linear function f, b is a constant. When x equals 0, f of x equals 30. What is the value of b? Now, when they say it is a constant, they mean it is a number, just a set number. They're not telling you what that number is because what would be the point of this question if they told you, right? Right. They're not, all they are telling you is it is not a variable. X is the variable. X can vary, it can change, but b does not change, it is constant. So I have this function, and when I have a function, f of x, sometimes you'll see g of x, h of x. F of x is the most common. It's what you're most likely to see on an SAT problem. If I have a function, it is telling me that I will put in a number, x, into whatever equation is over here, then I'll boop, 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 do my math, and I will get a value, and I will call that value f of x. So, for example, if I said x plus 3, and then I say, what is f of 2? It's saying, if x is 2, everywhere there's an x on the right side of this equation, I need to replace that x with a 2 and then do that math. So if I did that here, I replace that x with a 2, then I add 2 plus 3, and I get 5. So f of 2 would be 5. This process is called evaluating a function, and that's what they're asking you to do here, is to evaluate this function, and then to figure out what b is. It's a combo. So I have my original function, f of x equals x plus a number. It is a set number, but we don't know what it is yet. It is b. Calling it that for now. And it's saying when x is 0, when 0 is in here, and so I would plug 0 in everywhere else, and then I would do the math, then what does f of x get? What do I get after I do this math? It says I would get 30. So what is the value of b? So if we plug all these numbers in, when x was 0, b got added to it, I did that math, and then I got 30. So this equation represents what happened. 30 equals 0 plus b. Now, any number plus 0 is just that number. So I can combine those together and just have 30 equals b, and I don't have to do any more math. There's my answer right there. I don't have to subtract anything from either side. I'm good. B is equal to 30, and up here, that is D. My answer is 30. Number 9, P of t equals 1800 times 1.02 to the power of t. The function P gives the estimated number of marine mammals in a certain area, where t is the number of years since a study began. Okay, so this function P of t, if I do the math, I'm going to write the whole thing out. Similar to the previous one, we were talking about evaluating functions. So this one says if I pick a number t, and I haven't written down yet what t means, I'm just looking at this first part, p, this function p If I plug in a number for t and I do all this math, I am going to get the estimated number of marine mammals in an area. Okay, so I'm going to write that down. That p of t is meaning the estimated number of marine mammals, M&Ms. Okay, and then t says is the number of years since the study began. Okay, so t for time, I'm thinking. Weren't they creative? Number of years since the beginning of the study, since the beginning of time. No, since the beginning of the study. Since the beg. No, since the beginning. Let me write it all out. That looked weird. Since the beg. Since the beginning. How many years it's been. Now their question is, what is the best interpretation of P of 0 equals 1800 in this context? Anytime you see what is the best interpretation, you're going to have to read, or you should read, I would recommend you read all 4 of the options. And be aware that when they ask for the best, you may find more than one that could fit. And again, you want the bestest. You want the one that works the best in this best interpretation here. That fits the best. Okay, so what I like to do in these cases is I like to come up with my own definition of what P of 0 equals 800 would mean. And then I'll see which of these 4 answers is the closest match to what I've already decided the answer is. Sometimes I recommend looking at the answers first, but a lot of times these are so similarly worded that it can be confusing because they're so close that you can very easily misread them and get the wrong answer, and we don't want that. So I'm going to come up with my answer first and then see which one matches it. All right, so let's look at what we have. I've got P of t, I have my equation, and I'm told that if I plug in a number for t and I do this math, I get the estimated number of marine mammals in that number of years since the beginning, t. And the one we're looking at is P of 0 equals 1800, etc. So t is 0, so that means 0 years since the beginning. Well, if it's 0 years since the beginning, it's the beginning, right? When t is 0, this study hasn't begun yet. It's right at the first point. So it is the beginning. The start. I should have just written start instead of slowly, ponderously writing beginning every time. Since the start, it is the first year, the first moment. They haven't really started tracking the change yet. They've just started. And in that 0, and they did the math, they got 1800. Well, what did it say up here is when you get the math and you get a number, what that number is. It said that number is the estimated number of marine mammals. Okay. So at the beginning, the estimated number of marine mammals was 1800. So that's my hypothesis. I think that this equation, P of 0, or this statement that P of 0 equals 1800, means that at the very beginning, before they even started doing anything, there were 1800 marine mammals. All right, so let's look at their options and see which of those is the closest to that. A, the estimated number of marine mammals in the area was 102 when the study began. Nope, not that one. We think it was 1800 when the study began. B, the estimated number of marine mammals in the area was 1800 when the study began. Oh, that looks like it. But again, this is a best one. So let's look at C and D just to make absolutely sure that neither of those is better than the one I've just found. C, the estimated number of marine mammals in the year increased by 102 each year during the study. Now, I'm not going to do the math here because it's not necessary to this question, but saying increased by 102 each year, this is an exponential function. It's not going to be increasing by 102, a flat rate each year. That would be a linear equation. It's increasing by like a set step up each time. This is an exponential function. So it's increasing by a percent. This represents a percent of a 2% increase each year. That's what that O2 means. So this is not a good answer. Even if they said increased by 102 the first year or the second year or something like that, you wouldn't have to do the math to determine whether that was right, because they weren't saying, is this fact true that it increased by 102 in a given year or each year? The question wasn't that. The question is, what does this mean? This equation right here, and this equation right here saying P of 0 equals 1800 has no relationship whatsoever to a yearly increase. No. So that one's out. Let's look at D. The estimated number of marine mammals in the area increased by 1,800 each year during the study. Again, that's a flat rate increase. That would be a linear increase where it's just going straight up. It's linear. It's steady. This is exponential. It's increasing by 2% each year. It's going to go up like that. So no, this does not represent this equation in general, and it certainly does not represent this statement that P of 0 is 1800. I keep talking about the best wording up here, and it's because I really want you to pay attention to that when it says the best interpretation. They were pretty kind in this one in that only one of these is actually accurate. The other three are not. A lot of times when they say the best, there will be two in there. Generally not three. I'm trying to think if I've ever seen three. I don't think so. But a lot of times there will be two that are correct, but one is better. So for example, this one might have done a correct statement by saying this is going to increase, this population increased by so many mammals in the first year. And if you did the math, you go, wait, it did increase by that many mammals in the first year. What do I do? They're both right. When that happens, when that kind of thing happens, you want to go back to the question. In this case, it was asking what P of 0 equals 1800 means, not what are some true statements about this equation. That's where they'll get you. So yeah, be careful on those when it says best, because you could have two options. But this one, they were kind of nice. It's rare. It happens. B is the only one that is absolutely true, and it is our answer. Number 10, a manager is responsible for ordering supplies for a shaved ice shop. The shop's inventory starts with 4,500 paper cups. Okay, so 4,500 paper cups. Paper cups. And the manager estimates that 70 of these paper cups are used each day. Doesn't seem like really a lot of business for this shaved ice shop, but okay, apparently he's doing all right for himself. So 70 are used each day. Based on this estimate, in how many days will the supply of paper cups reach 1,700? Okay, so 70 cups per day. This is one I think it's better not to necessarily make an equation for it. We can, but I think it works better just as sort of a writing out things and looking at what these numbers represent kind of problem. Okay, so it's going to go from 4,500 down to 1,700. How many paper cups are gone from when it gets to 4,500 to 1,700? How many were used? There's the word, used, not gone. The paper cups are gone. They just vanished. No, they were used. People are selling shaved ice like there's no tomorrow. So how many were used? We're going to subtract the 1,700 from 4,500 to see how many were used. Okay, so 4,500 minus 1,700 is 2,800. So 2,800 cups were used by this store. And if there were 70 cups used every day, how many days did it take to use 2,800? So for that, we need to divide 70 into 2,800. Little shortcut there, if your teacher never showed you this. When you have a number that ends in a 0 that's being divided into a number that ends in a 0, you can just go boop, boop, and scribble out those zeros and just divide the smaller numbers and you will get the same exact correct answer. I promise. Okay, so 7 into 280. 7 doesn't go into 2, but it does go into 28 4 times. Multiply back 4 times 7 to get you 28. subtract, get a 0, bring down the 0, 7 goes into 0, 0 times. So 40 in 40 days, that's what we were trying to figure out, is cups per day. How many days? 40 days. That is our answer. How many days will the supply of paper cups reach 1,700? In 40 days, which is B. If we were wanting to do this in an equation, an algebraic equation, you would say we're trying to solve for how many days. I would say that days would be my x, and I would write it as 70 cups times how many days would be equal to 4,500 minus 1,700, where we started, and then what would we get to, and how we use. If I don't think that's intuitive. A lot of the equations, a lot of the times where they ask you, you have these sort of complicated or just lengthy word problems, a lot of verbiage. They love their verbiage. A lot of kind of like throwing up smoke with all these, words and phrases. A lot of times there's sentences that have nothing to do with the end result, and they're just like, oh, they're just messing with you. Totally happens. And yet a lot of times using an equation will help you sort out that problem. This one, because you've got this more unusual setup, I don't think it's as helpful. The ones that I would recommend using an equation for is where you say, this is that. And what I mean by that is if you hear something like 5 times a number is 3 more than 6 times another number. That kind of phrasing, they are laying it out for you. They are telling you the equation that they want you to do. Something like this, it's not doing that. So if this would make sense to you to set it up like this, I just don't think it's as helpful in this particular case, because, you don't have to use an equation. You can do it just the way we did it, where we're just kind of looking at the numbers and feeling out what's going on, and then figuring out the solution works just as well. But as always, do what works best for you, what makes the most sense for you. Number 11, y is greater than 4x plus 8. For which of the following tables are all the values of x and their corresponding values of y solutions to the given inequality? Okay, we're going to be looking at our 4 answers and seeing which one has all, values that will fit. And if we look at our x values, each one of these has the same x values, 2, 4, and 6. So the most effective thing we can do is look at our 4 options and see if we can find a number x where every single chart here, table, there's the word I'm looking for, every single table here has a different y value. If I start with just 2, it's possible I could only eliminate 2 answers, because this one has 19, that one has 8, but these both have 13. So if I plug, 2 in here for x and I get something where 13 would work, I've only eliminated 2 options. So my odds are better at eliminating more ones or narrowing in the field by picking one where every single value is different. Now, granted, this is an inequality, so it's not, the perfect solution. I still may only eliminate a couple of them, but your odds are better at eliminating more if you pick a value to put in where every single table has a different outcome. Okay, so let's start not with 2, but with 4. I'm going to use the 4 value. I'm going to plug 4 into here. Y is greater than 4 times, my x is 4, plus 8. I don't know why I put that extra parentheses. It's just hanging out there. So y is greater than 4 times 4 is 16, plus 8. Y is greater than 16 plus 8 is 24. So I'm going to look over here and see which of these has a y value that's greater than 24. All right, this one does, 30, so that's a possibility. 16, nope. 18, nope. 21, nope. Looks like we have our answer here with A. It's always a good idea once you've zoomed in to check it just to make sure that the other 2 work. And this is a good way to check and catch careless errors. Because if you just check one and you're like, hey, this is the right answer, and you move on, if you made any mistake in your math over here, or in some cases where you have to put in multiple values, some problems where you have to put in multiple values, if there's a mistake anywhere in there and you've only checked one, that can slip through. But if you check the rest of them and something doesn't add up, then you can figure out, I think I made a boo-boo. All right, so let's check 2 and 6. Let's see what happens if we put 2 in here. Y is greater than 4 times 2 is 8 plus 8. Y is greater than 8 plus 8 is 16. Yep, sure enough, 19 is my value, so that one checks. And then finally 6. Y is greater than 4 times 6 is 24 plus 8. Y is greater than 24 plus 8 is 32. And my table says 41. Ding, ding, ding. A is my answer. Number 12, which expression is equivalent to x squared plus 11, all of that squared, plus x minus 5 times x plus 5? And we are given 4 options here where like terms have been combined. So we need to create some terms so we can start combining. We have x squared plus 11 all squared plus x minus 5. Whoa. Stylus went really wonky there. X minus 5 times x plus 5. Now, there is no harm, no foul in using FOIL and distributing and doing the same up here, writing this out as x squared plus 11 times x squared plus 11, and then using FOIL, distributing that way. You will get the right, the right answer, you'll get the right terms. But you also can use shortcuts if you remember those. If you remember the shortcuts for perfect squares and difference of squares, you can do that. So I'm going to show you what those are. The shortcut for perfect squares says that if I have a plus b squared, it is equal to a squared plus 2 times a times b plus b squared. So I can do that with these up here. This is my a, this is my b. So first my a squared x squared squared, x squared times x squared is x to the 4th. 2 times a times b, 2 times x squared times 11. 2 times 11 is 22, times x squared is 22x squared. And then my last term is b squared, so 11 squared is, erase that for room, 121. All right, this one has another pattern, difference of squares. Says when I have this pattern of a minus b times a plus b, it is equal to a squared minus b squared. That is our pattern. A minus b times a plus b. It's such a handy little one to remember, and it's so common for students to forget it, and then the math comes back like, ha-ha! You thought you'd get away with forgetting it, but no, you have to remember it again. Completing the square, another one. If you're doing completing the square in algebra, never forget it. I know it's a pain in the neck. Don't forget it. You'll thank me later. Okay, so a squared minus b squared is my value. So I'm going to do that here. This is my a, this is my b. So my a, x squared, and then I subtract b squared. My b is 5. So minus 5 squared, or 25. All right, everything's been expanded now. I have all my terms, and I can combine like terms. Got an x to the 4th. I don't have any others, so that one stays the same. I have 2x squareds. I have a 22x squared and a 1x squared. When I add those together, I get 23x squareds. And then I have my constants, 121 and negative 25. So 121 minus 25 would be 96. So x to the 4th plus 23x squared plus 96. And sure enough, that BB. And that is my answer. Number 13. The function h is defined by h of x equals 8 over 5x plus 6. What is the value of h of 2? This section has had, this is like the third third question that's had evaluating functions as part of it. Okay, they ran an evaluating functions kind of mood. So evaluating a function, if you're watching these videos individually and not the full-length one with all of them together, I'll repeat what that is. And if, you just heard me say this, if you're watching the full-length video, hey, it's getting reinforced. What can you say? When I have a function, it is an input and an output. The input is whatever I write in this parentheses, and then I take that input and I go over on the right side, and wherever there's an x, because that's the variable I'm replacing, I'm going to put that input. And then I do all my math, and what I get is the h of x value. So in real numbers, it would be like if I had, say, h of x is equal to x plus 2. And then they asked, what is h of 3? They're saying, I want you to plug in everywhere there's an x on the right side. There's only one in this case. I want you to put a 3 in for it. And then tell me what you get. So I put in a 3 and I get 3 plus 2 equals 5. And I go, okay. Then my output is 5. H of 3 is 5. And that is what evaluating a function is. So if they ever tell you to evaluate this function for 5 or that kind of thing, that's what they mean. So here they're telling us to evaluate it for h of 2. So they want me to take 2 here. Boom. And then wherever there's a 2 on the right-hand side, if there's an x on the right-hand side, I should plug in a 2. There is only one. So I'm going to plug in a 2. So 8 all over 5 times 2 is 10 plus 6. 8 over 10 plus 6 is 16. Simplify this. This is 1/2. So you can enter this into your answer key. This is a student-produced response. So you can enter it as 1/2 or as the decimal 0.5, and that is your answer. Number 14. 3 and 5 are the sides of this right triangle. There's a note, the figure is not drawn to scale. The figure shows the lengths in inches of 2 sides of a right triangle. What is the area of the triangle in square inches? You may be tempted to try to figure out the length of our third side of the hypotenuse here. It is not necessary. It's just not. This is just an area of a triangle. Anytime we have an area of a triangle, our formula is area is equal to 1/2 times the base times the height. This is one of the formulas that is provided for us by the SAT College Board. They're being nice, giving us a few little formulas. Not everything, but a few. They're being a little bit helpful. What is the base and what is the height? The base is always going to be the bottom. What it's sitting on, what it's resting on the bottom, that's the base. Oop, undid my height. What is the height, though? The height can be a little tricky. The height always, no exceptions, will involve a right angle. So if I have a triangle that is like this, like that, my base is going to be here at the bottom, what it's sitting on, and then the height must be perpendicular to that base. And you have to see a right angle or have them tell you there's a right angle there. Have to. So if the triangle is like this, a right triangle, this would be my base and this would be my height. The side, the length that is perpendicular to that base. The one little oddball that they sometimes throw in is if you had a triangle like this, you'd have this coming down like that. That is going to be your height. Right there is your height. And this is your base. Don't include that part. Sometimes students want to do that. They want the base to go all the way out here. Nope, it is only this part, but that little line coming down, forming the right angle, perpendicular to that base, that is going to be your height. So in this particular case, they haven't really thrown any wrinkles at us. It is pretty straightforward. Our base is going to be down here, and this coming down perpendicular to it is my height. So it is 1/2 times my base times my height. 5 times 3 is 15. 15 times 1/2 is 15 halves or 7.5. Don't put it in as 7.5. No, it needs to go in as 15 halves or 7.5 for you to get the right points. Get the points for that, to get it marked right, to get the points for that. Yeah, this is a holdover when they would do like 7.5 like that. Like, wait, that looks like 71 halves. That can't be right. So always put it in as either like 15 halves or 7.5. As a little bonus thing, if you were to rotate this triangle, like if you were to rotate it this way so that it was sitting up like that, and this was 3 and this was 5, would the base then be 3? Yeah, same difference. I'd say, okay, 1/2, my base is 3 and now my height is 5. But as you can see, you're still going to get 7.5. It gets the same either way. All right, on to 15. Number 15. The graph models the number of active projects a company was working on X months after the end of November 2012, where 0 is less than or equal to X is less than or equal to 6. According to the model, what is the predicted number of active projects the company was working on at the end of November 2012? Okay, so we're told this is the number of months down here, and these are the number of projects, because X months, where X is between 0 and 6. All right, so at the end of November 2012, well, it's saying this is showing the model of how many months after the end of November 2012. So this is 1 month after the end, 2 months after the end, 3, 4, 5, 6 months after the end. They don't want to know any of that. They want to know how many was it working on at the end of November 2012. So that is, boom, here we go, right there at the beginning. The very beginning, 0 months after the end of November 2012 would be the end of November 2012. And if we look at the coordinate there at 0, that's showing 5. Yeah, that's all it is right there. 5. 0 months after the end of November 2012, they were working on 5 projects. And that is B. This is one of those, I think it's almost tricky in its simplicity, because I sat here for a second looking like, it can't be that, right? It can't be that. It's got to be, I got to be missing something. I got to be missing something. No, sometimes they really are just like, yeah, they're giving you all this, and then all they wanted was that first thing that they asked you. So yeah, just read carefully, and yeah, sometimes it is just that direct. 16. The relationship between two variables x and y is linear. So that means if we graph x and y coordinates, we're going to get a straight line of some variety. No curving. No curving. No capes. So the relationship between two variables x and y is linear. For every increase in the value of x by 1, the value of y increases by 8. When the value of x is 2, the value of y is 18. Which equation represents this relationship? When we're talking about an increase in the value of x, that is a change in x. The value of y increasing by 8, that's a change in y. The definition, or the equation for slope, is change in y, go on stylus, divided by change in x. And here they're giving us those values. We don't have to calculate them. Sometimes we have to calculate them. We have to take our, like if we're given, two ordered pairs, x and y values, and then we're like, okay, we're going to take, y2 minus y1 over x2 minus x1. That formula may look familiar to you. That's a very common thing we have to do, or we have to look at a graph and we have to count out, so if we have a line, we go like, okay, it goes up this many, it runs that many. They've done all that for us. Well, they're telling us right here that the x value is increasing by 1. That number is going up by 1. So if we're looking at it on, the xy graph, it's going this way by 1. And every time that happens, the y is going up, increasing by 8. So the change in x, the one on the bottom, is a positive 1. It's increasing value by 1. And on top, the change in y is a positive 8. Okay, so this is 8 over 1, or just 8. My slope is 8. Now, if I look at my answers over here, all of these are in slope-intercept form. That is, y equals mx plus b, where m and b are numbers, or constants. That m value right there, that is always going to be my slope, and my b is always going to be, write it up here because I'm running out of room, my y-intercept. Y-intercept. So the m, the coefficient of the x, is the slope. Well, look at my answers. So here I have one with a slope of 2, slope of 2, slope of 8, slope of 3. There is only one line here that has a slope of 8, which is what I need. So that's enough right there for me to say C is my answer. But it never hurts to be sure, and they've given us a way to be sure. It says when the value of x is 2, the value of y is 18. So I can plug in a 2 for x and see if I get 18 for y. So 8 times x, 8 times 2 plus 2. 8 times 2 is 16. 16 plus 2, why, that would be 18. That checks out. I've confirmed it. C is my answer. Number 17. P equals n times 19 minus c. The given equation relates the positive numbers p, n, and c, which equation correctly expresses c in terms of p and n. When we say expressing something in terms of something else, it sounds fancy and it sometimes looks very complicated. But all they're wanting you to do is when it says expresses c in terms of p and n, is they want c by itself and everything else over on the other side. That's what they mean. So if I gave you something like, say, y plus x equals 5, and they said, I want x in terms of y. They mean I want x equals, and I want the y, anything else with it, to be on the other side. And so you just do whatever algebra you would do to move everything over. You're not solving anything in the sense of you're not figuring out what x means, what number x is equal to, or what number y is equal to. It's impossible. You've only got one equation and you've got multiple variables. It can't be done. What you can do is put all of those constants over on one side, and you have the one that you want to be expressing by itself. In this case, it's c. So we want the p, and we want the n, and we want anything else over here on the right-hand side. So let's look. We've got p equals n times 19 minus c. I want c by itself, so I want to undo what's been done to c. We have this 19 minus c, and I've got this n being multiplied by it. I'm going to divide everything by n first to get rid of it from the right-hand side. Okay, so I'm going to divide everything on the right by n. I'm going to divide the left by n. So now I've got p divided by n on the left, and I have 19 minus c on the right. Now, there are two ways that you can look at this and solve this. If I get 19, if I move the 19 over here, I'm going to be left with a negative c, and then I can deal with that negative c. Or I can move the c over there, which would make it positive, and I can move the p over and back over there. If that doesn't make sense, I'll show you both ways to show you what I mean. So I'm going to write it over here as well. So p over n equals 19 minus c. And you'll see that you get the same answer both ways. So over here on the right, the green, the p over n equals 19 minus c. I am going to, so I have a positive 19, I'm going to subtract 19 from both sides. And I am going to get p over n minus 19 equals a negative c. Well, I don't want a negative c. It has to be a positive c. So I'm going to multiply everything on the left and everything on the right by negative 1. It's just going to flip the signs of everything. So over on the left, I will get a negative p over n plus a 19 equals positive c. And I've done it. Now over here on... Whoa! Oh my goodness gracious. I was just trying to highlight that so I could move it over a little. Sorry. I don't know why that was so funny to me, just everything spazzing suddenly. Sorry about that. Or me making it spaz suddenly. All right, so on the left we have p over n equals 19 minus c. So in this version, I'm going to make c positive by adding c to both sides, which I can do. And then I have p over n plus c equals 19. And now I need to get that p over n, and it's, a positive p over n. I need to get rid of it. So I'm going to subtract p over n from both sides. And I end up with c is equal to negative p over n plus 19. And looky there, I've got the same thing both ways. Yeah, as long as you're careful with moving things around, you're going to get the same answer regardless. So you get a positive 19 and a negative p over n, or negative p over n plus 19. And as we look over here, up at the top of my answers, this is the one that they're wanting, because I had it written as negative p over n plus 19. You can reorder those. It's totally fine and get 19 plus a negative p over n, or in other words, 19 minus p over n, and that is D. One little thing of note, one thing that sometimes happens with these kind of problems, a setup that they will give you, is when, get rid of all of this, is when you have something, let's say, like this, C over A equals B, and they tell you they want A in terms of C and B. And that can be very confusing, because then you're like, whoa, but I need A by itself. How do I get rid of the C? How do I get rid of the C and just have the A left behind? Because C's being divided by A, what do? You have to move the A over here and then deal with what comes next. This is a very common thing, so I'm just throwing it in here as a little piece of bonus information. You want to multiply both sides by A, in this one, because we're dividing by the A. And you're going to have the C on the left, and then B times A on the right, and then you're in a position to get A by itself. Since A is being multiplied by B, then you divide both sides by B, and you get A is equal to C over B. Very common sort of thing that they do, because it can, kind of throw you for a loop when you first see it. All right, moving on. Number 18, w squared plus 12w minus 40 equals 0. Which of the following is a solution to the given equation? I do not recommend doing this one by graphing, because if you look at the answers here, you can see there's a square root in every single one of them. So when you go to graph it to get your solution, and you're going to be looking for a parabola, and it's going to cross somewhere, and you're going to be looking at those points of intersection of the x-axis, and that's going to be your answer, you're going to get this irrational non-repeating number, decimal, because it's a square root of 19. Now, if you really want to, could you graph this and then zoom in and write that down, and then convert, all four of these into decimals, and then see which one matches? You could. I don't know that that's a more time effective, cost effective, a more effective use of your time. That's going to be for you to judge. The two ways that you solve this on paper, which anytime you see square roots in there, these are the two ways you're going to be thinking about, are completing the square and quadratic formula. Now, if you look at the answer key for this, they recommend completing the square. Me, I used quadratic formula when I took this, but I always take the tests before I explain them to everyone. That's only fair, right? If I shouldn't be telling you how to do it if I can't do it myself in a timed scenario. So I'm going to show you both ways. I don't think most students are that familiar with completing the square. I think a lot of students, in my experience, they learn it for the test and then they forget it. Which, side note, don't do that. Completing the square comes back all the time in various math levels. It just does. Yeah, if you're planning on taking any math after the SAT, don't forget how to do completing the square. All right, so my method that I used first, I used the quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Is it unwieldy? Yes. Is it important to memorize it? Also yes. The b's, a's, and c's here are referring to when I have a quadratic in the form of ax squared plus bx plus c equals 0. That is important that it equals 0. The a is the coefficient in front of the x squared. If you don't see one, like in this case, it is an invisible 1. The b is the coefficient of the x, and the c is the constant that's by itself. And the negative, if there is, like the positive and negative, that does go with them. Like up here, this negative goes with the 40. An important thing to note in this equation up here, when it says negative b, It means the opposite of whatever sign b currently is. So if you looked up here and it had been a negative 12, then it would be the opposite of that, or a positive 12 there. It doesn't just mean, oh, it's already negative, so I don't have to change it. Nope. You have to make it the opposite. Okay, so for this one, our A is that invisible 1, our B is a positive 12, and our C is a negative 40. So we start plugging things in. The opposite of positive 12 is negative 12 plus or minus the square root of 12 squared minus 4 times 1 times negative 40. That's why those positive negatives so important. And on the bottom, 2 times 1, or just 2. And at this point, it is just being careful with your math. I think, honestly, the hardest part of this is memorizing this equation and getting it down solid to the point where you know you have written it down correctly. And then it's just being careful in your math. So negative 12 plus or minus the square root of 12 squared is 144 minus 4 times 1 times negative 40. 4 times 1 is 4. 4 times negative 40 is negative 160. So minus a negative 160 is plus 160 all over 2. 144 plus 160 is 304. So I'm going to, there we go. The square root of 304. Now, if you're going to be simplifying this square root of 304, normally I'd be telling you things like do a factor tree or divide by 2 and see what you get. Divide by 4, see if you can keep doing that. We have a huge clue over here in our answers. Every single one of them has square root of 19 in it. So I'm going to divide 304 by 19 and see what I get, because something's going to factor out of this. And sure enough, when I do that, I find out that 304 is equal to 16 times 19. So when I have a square root, I can simplify it. Since this is square root of 304 is the square root of 16 times 19, I can split that up into the square root of 16 times the square root of 19. Square root of 16 is 4, so it is 4 square root of 19. Okay, so now I can put that in there, 4 square root of 19. And now I'm going to look for any factor that goes into these three constants. It has to go into all three of them for me to be able to take it out. If it just goes into 2 of them, no dice. It has to go into all 3. 2 goes into negative 12, it goes into 4, and it goes into 2. So that's what I'm going to do. I'm going to take it out. If I take 2 out, I divide negative 12 by 2, I get negative 6. If I divide 4 by 2, I get 2. Divide 2 by 2, I get 1. So that is going to be negative 6 plus or minus 2 square root of 19. And that is D. Because it said, which of the following is a solution? And that plus or minus means it could be negative 6 plus 2 square root of 19 or negative 6 minus 2 square root of 19. And that's D. None of the others apply. The way that they wanted you to do it was completing the square, which is just as valid. But again, I just don't think most students remember it. I've just come across so many times where it pops up again later and the students are like, what are you talking about? Completing the square? I've never seen that before in my life. I guarantee you they have, but everyone forgets it. Don't feel bad about it. It just happens. Okay, so the idea behind completing the square is the perfect square trinomial, which says that a plus b squared is equal to a squared plus 2 times a times b plus b squared. So the idea is if you have these first 2 terms, you come up with a third term that would turn this into a perfect square. And you go like, wait a minute, what do you mean just if I have first 2 terms? I've got 3 terms up there. No, that's the fun part. Right, so when you are completing the square, and I'm just going to rewrite this up here in a little, be a little reference for you. A squared plus 2 times a times b plus b squared. Okay, when you are completing the square, you have to separate those first 2 terms because you're trying to create this perfect little happy square. And then the other term that's there on the end, you have to move it over here to kind of get rid of it, to put it out of the way. So that's what we're going to do. So I'm starting out with it, that it's over here. I want to get rid of it. I want the w squared plus 12w to be by itself. So I'm going to add 40 to both sides. I get w squared plus 12w. I'm going to leave a gap, equals, on the other side, 40. All right, w squared plus 12w. I am trying to convert this into a perfect square by following this pattern. So this central term, 12w, is going to be equal to 2 times whatever my a term is times whatever my b term is. What is my a? Well, this first one right here is a squared. W squared is a squared, so my a is just w. A side note, which doesn't apply in this case, but if they're asking you to complete the square, you need to know this if you're going to use it in the future. If you ever have a coefficient in front of this first square, it's going to be an x squared, a w squared, it's going to be a variable squared. If there is ever any number in front of this, I don't care what the number is, you have to divide everything by that number to get rid of it before you can do this step that I'm doing. Will it create unwieldy fractions that make your life miserable? Oh yes, it will. Absolutely. It's another reason why people don't like completing the square, because you get crazy fractions. But just, yeah. You have to, it has to be just a plain x squared, w squared, what have you, so that your a term is just x or w, like that. All right, so my a is w. So this right here, 12w, is equal to 2 times a times b, and my a is w. So that is equal to 12w. So I'm going to get rid of this 2 by dividing both sides by 2, and I get that w times b is equal to 6w. And then to find out what b is, I'm going to divide both sides by w. I'm just left with b on the left and 6 on the right, so my b is 6. So again, my a is w and my b is 6. So my perfect square would be w plus 6 squared. So what would that third term be? It's going to be b squared. 6 squared is 36. So I'm going to add 36. But I have to do it to both sides. I can't just do it on the left. I have to do it on the right also to keep it nice and pretty. So on the left-hand side, I'm going to get w plus 6 squared, because I've converted it into that. And on the right, I have 40 plus 36, which is 76. So now I need to solve. So I need to undo what's been done to w. So I need to take the square root of both sides to undo this square. Take the square root of that side. And on the left, I'm going to get w plus 6 is equal to the square root of, why did I write 2? 76. And then going to subtract 6 from both sides to get rid of that. And I get w is equal to negative 6. And because it's a square root, we have to say plus or minus square root of 76. But I have to make sure, I have to simplify it. And again, because all my answers have square root of 19 in it, I divide 76 by 19 to see what I get. And sure enough, I get 4. So I know that square root of 76 is equal to the square root of 4 times 19, or square root of 4 times square root of 19. Square root of 4 is 2. So 76, square root of 76 is the same as 2 square root of 19. Again, same thing. Negative 6 plus or minus, and the plus 1, there is d. I know so many students just don't know completing the square. They just don't. If you want to use it, again, it's really good to know how to do it. I know it's not fun. I know it's not fun. Believe me, I know. And I know nobody likes completing the square. But it's a good thing to have in your arsenal, your toolkit. The only real time I see completing the square on the SAT outside of this one where they're suggesting you use it, but you don't have to, is when you're dealing with formulas of circles. That comes up infrequently, but it's usually more like in your number 25 to number 27, those more high end, like end of the line, like really challenging sort of puzzle problems that come at the end, they'll sometimes throw in things about equation of a circle. And you do often need to know completing the square to solve those. It's a little shortcut for you right here. I was showing you why it all works, but the little shortcut method, when you get to this point, when you've moved this to the other side and you just have this, the shortcut method to figure out what this is, you take this number, you divide by 2, and then your answer, you square it. It's always going to be dividing by 2. Because of what I was showing you before, where it's 2 times A times B, and your A is always just like that plain X or W. So you're dividing by that 2 every single time to get your B. So in this case, 12 divided by 2 is 6. 6 squared, positive 36. Add it to both sides. Go from there. So this is really a case of pick which method you like, for this kind of problem. But because they showed you that in the answer key of completing the square, I wanted to show you what exactly they were meaning by that. But for me, I just do quadratic formula. All right. Number 19. The table shown summarizes the number of employees at each of the 17 restaurants in a town. Which of the following could be the median number of employees for the restaurants in this town? They're testing our knowledge of what median is for a data set. So if I have 1, 2, 3, 4, 5 terms, I'm not writing the number 1 5 times, I'm just saying if I have 5 terms, the median would be the term that is physically in the middle. So there's 2 terms, it's physically in the middle. That's the median. It doesn't mean it's the average. It doesn't mean, because you could have like 1, 1, 1, 8, 23. 1's the median because it's the number that's physically in the middle of that list. So if you have an odd number of terms, there will be a number that is precisely in the middle. If it was an even number of terms in the data set, let's say 1, 2, 4, 10, you're like, wait, there's not a number that's physically in the middle. What do? You take the 2 numbers that are closest to that middle point and you average them. So here it'd be 2 plus 4 is 6, divided by 2 is 3, so the median would be 3. Now in this data set, we're told that there are 17 restaurants in a town. So there is going to be a median. Well, if it's 17, you go down 1, and that tells you, and you divide that by 2, and that tells you how many numbers are on each side and which number is in the middle. So if there's 17, you go down by 1, that would be 16. Divide that by 2, and that means there's 8 restaurants on this side, 8 restaurants on this side, 1 in the middle. 8 plus 1 plus 8 is 17. That's just a little methodology. If it makes more sense for you to go like, okay, 1, 2, 3, 4, 5, 6, 7, 8, do that, that's fine. We want you to get the answer right. That's the most important thing. The method is not as important. We want things that are fast, but we also want things that you understand and you'll get correct. Okay, so there's going to be 8 on the left, 8 on the right, 1 in the middle. So it will be the 9th restaurant if I'm counting out 1, 2, 3, 4, 5, 6, 7, 8. 1 in the middle is number 9. Then 10, 11, 12, 13, 14, 15, 16, 17. Okay, so the 9th restaurant. Where in this list of restaurants would the 9th one be? Because we're starting here and we're going forward. Because we'd be writing the number of employees. So let's say if I had, for instance, I'm just going to do the spaces like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay? And it's telling us, and let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the one we want. Okay, the median. It's telling us that there were 2 restaurants that had employees between 2 and 7. So this restaurant, the employees are going to be from 2 to 7. This one, they're going to be from 2 to 7. Then it says there's 4 restaurants that had 8 to 13. So that's going to be 1, 2, 3, 4. These 4, they were between 8 and 13 restaurants. Then it says there's 2 restaurants that were 14 to 19. So, okay, so 1, 2 restaurants had between 14 and 19. Then it says there were 7 restaurants that had between 20 and 25. So 1, 2, 3, 4, 5, 6, 7 restaurants had between 20 and 25. And then finally, there were 2 restaurants that had between 26 and 31. Well, our median right here is firmly in the 20 to 25 category. So that's the only possible number of employees could be. It has to be between 20 and 25. So I look at my options here, 2, 9, 15, and 21. The only one of those options that fits in this 20 to 25 is D, 21. That could be the median number of employees. Number 20, what is the y-coordinate of the y-intercept of the graph of 3x over 7 equals negative 5y over 9 plus 21 in the xy plane? There's several different ways you can do this. One, you can choose to graph it. You can graph this and then you can zoom in and look for the y-coordinate of the y-intercept. Be extra careful if you do that because this is a student-produced response. So there's no multiple choice here to kind of let you know if you're heading in the wrong direction, like if you get an answer that's not on the list. So what you'd be looking for, the y-intercept, is going to be where it crosses the y-axis. And wherever that point is, you're going to zoom in, you're going to look at the 2 points, and you're going to get the y-coordinate of that. Because the x-coordinate is going to be 0. Anything that's on the y-axis, the x-coordinate is going to be 0. So that's how you do it if you're graphing. If you are doing this mathematically, there's actually a couple of ways you could do it there too. You can say, well, I know when it's the x-intercept, like I just said there, the x-coordinate is going to be 0. So I'm going to plug 0 into this equation, and then I'm going to solve for y. Absolutely valid way to do this. So 3x over 7 equals negative 5y over 9 plus 21. And if I were to plug in 0 for x, I would get 3 times 0 is 0 divided by 7, and that's just going to be 0 over here on the left, equals negative 5y over 9 plus 21. So I need to solve for y, so I might subtract 21 from both sides there to get rid of that little 21. And so on the left, I will have now a negative 21, and on the right, negative 5y over 9. Now, y here has been multiplied by negative 5, then divided by 9. I need to undo that, so I'm going to undo that divide by 9 to multiply by 9. So on the left, negative 21 times 9 is negative 100, my wrong color, negative 189 equals negative 5y. And then, I always write too big. And then I want to undo that multiplying by negative 5, so I divide both sides by negative 5, and I get that y is equal to 37.8. All right, that's the second way. There is a third way you can do this too. You can absolutely do this a third way, and you're also going to get, like you would the other 2 ways, 37.8. The third way here, because we're looking for the y-intercept, is you put this into slope-intercept form. So that is, you solve for y. So to solve for y, I need to undo what's been done to it. I'm going to subtract that 21. Subtract 21 from both sides. So on the left, I will have that 3x over 7 minus 21 equals negative 5y over 9. And to get rid of that dividing by 9, I need to multiply everything on both sides by 9. So on the left, and you know what, honestly, I don't even care about this. All I care is about that negative 21, because that's going to be what my y-intercept is. But if I was doing this for myself, or when I did do this for myself, I didn't even do the math of multiplying that by 9 because I'm like, it doesn't matter. All that matters is this negative 21. That's going to be where my y-intercept is. But for you guys, I make the sacrifice and I multiply fractions here. So 9 times 3x over 7 is 27x over 7 minus 9 times 21 is 189. And it equals on the right negative 5y. Then I'm going to divide everything by 5, by -5. So you're dividing by -5. Another way of looking at this is multiplying by -1/5, which is the way you need to do that if you have a fraction. That's why I didn't deal with it. So if I multiply everything by -1/5, which is again the same as dividing by -5, I am going to get a -27x over 35 minus, putting it in decimal form, 37.8 equals y. And that's actually going to be, plus 37.8 because it was a negative times a negative plus 37.8. And that is another way you can do it. And then now that is your y-intercept of 37.8. The second method, the one where plugging in 0 and solving, is the one I believe that they put on the answer sheet. I actually used this way myself because I like writing things out. I'm weird. And then I checked it using the graphing, like, hey, yes, the graphing backs up. But yeah, all three ways, perfectly fine. Do whichever one you wish. 21. The graph of y equals 2x squared plus bx plus c is shown, where b and c are constants. What is the value of b times c? There's a couple different ways that you can do it. This, if you've been watching these in sequence, or you've been watching the video where they're all back to back to back, you can see like the past 3 or 4 I've been saying there's like 3 or 4 ways to do this one. It's again, there's several different ways you can do it because they give you multiple points. They give you 1, 2, 3, 4, 5 points here that you can play with. So I'm going to write them all down. First they give you, have -3, 0. Then they give you -2, -6. And they give you -1, -8. And they give you 0, -6. And then they give you 1, 0. So they're giving you the x-intercept, they're giving you the zeros, they're giving you the axis of symmetry. A lot of different ways you can do this. So we need to solve for b and we need to solve for c. You can solve for b and c independently, or you can solve for one of them and use it to solve the other one. Doesn't really matter. It's whatever makes the most sense. I say that a lot, but it's true. I say it because it's true. All right, so here's one way if you want to solve for b. The formula for the axis of symmetry is -b over 2a. That x is equal to that. X is equal to -b over 2a. And here, the axis of symmetry, my x there would be a -1. And I know my a is 2. They gave it to us. So -b over 2 times 2 equals -1, or -b over 4 equals -1. So move this over. So I'm going to multiply both sides by 4 to get rid of that dividing by 4. And I get -b is equal to -4. So I just multiply both sides by -1 to get rid of those negatives. And I get that b is equal to 4. So, okay, so now I know b is 4. And I can solve for c either using, I can use that b to help me solve for c, because now I know 2x squared, I know my b is 4x plus c is the equation there, is equal to y. And now I can use any of these points and plug them in here and solve for c. I think these two are probably the easiest, because if I plug 1 in for x, I just get 2 plus 4, and I plug in the 0 in for y, I get 2 plus 4 plus c equals 0. That's a pretty straightforward one. This one is arguably even simpler, where you plug in 0 for x and then -6 for y. So I'll get 2 times 0, or 0, plus 4 times 0, or 0, plus c equals -6. C is equal to -6. Okay. Another way that you can get the b is you can actually start with solving for c and then use it to get the b. And what I mean by that is if I started over here and I didn't know, come here, eraser, come on, there we go. Even if I didn't know what the b was, I still know that putting 0 in, multiply b times 0 is going to be 0. So I still would get that same equation of 0 plus 0, regardless of what b is, plus c equals -6, and I would get that my c is equal to -6. And then you can, once you have that information, -6, then you can solve for b using one of these points. Like we use the b to solve for c, and then this way you have the c and you can use it to solve for b. Both work, you're still going to get that same answer. So like in this case, if I wanted to solve for b, I might go, okay, well, I'm going to use another point just to have a little fun with it. I'll say 1 and 0. Okay, so 2 times 1 squared, or 1, plus b times 1, plus -6 equals 0. So 2 plus b plus -6 equals 0. 2 plus -6 is -4, plus b equals 0. So I'm going to add a +4 to both sides and get b equals 4. Same result. They've given you a lot of options on that one. So now I have whichever way I chose to do it, however I wanted to attack it, whatever made the most sense to me. I can find that b is 4 and c is -6. And they don't want to know either of those. They want to know what's the value of b times c. 4 times -6 is -24. I'm debating whether it's a good idea to show those multiple ways, but, because people can view things different ways, I'm hoping that's helpful and not just like information overload. If it is, I'm really sorry. I'm trying to be helpful. Number 22. In 2008, Zina, cool name, earned 14% more than in 2007, and in 2009, Zina earned 4% more than in 2008. If Zina earned y times as much in 2009 as in 2007, what is the value of y? Well, they're not telling us how much Zina originally made in 2007, so I'm just going to call that x. She made x dollars, and then in 2008, she made 14% more. So how would I represent that? How would I say from 2007 to 2008, she made 14% more? What could I multiply x by? If I multiply x by 14%, which is the same as 0.14, I'm going to get 0.14x. Well, that's a portion of x. That's less than a fifth of x. That's not 14% more. If we're talking about how much more, this was the increase. It was this plus this is what she made in 2008, 14% more. So there's two ways you can look at it. You can look at it as saying, well, she made X amount of dollars in 2007. She made 14% more. And then I'm going to add those together to get 1.14x because it's 1x plus 0.14x. That absolutely is a valid way to look at it. Another way, which is probably more common in your math book, is saying, well, there was 100% of x that has to be included in this because this is just the increase, but when I'm multiplying, I want something here to indicate that this part doesn't go away. It's this plus this extra. Since this is 100% of what she made, this needs to be 100% plus 14%, or 114%. X needs to be multiplied by 114%, and 114% is 1.14. So x times 1.14 is 1.14x. Percents are one of those things where, because it's a fraction and it's a decimal and it's, there's always more than one way to look at it. Okay, so that's from 2007 to 2008. Then from 2008 to 2009, she made 4% more. All right, so now this is where, like I said, in this previous one, you could have just looked at it as 1 plus 1.14. This is where I think this method, it's a little easier to use it when you're having these compound, like interest on interest, compound interest. Okay, so in 2008, we have 1.14x, and then there's an additional 4%. So what am I going to multiply it by? And I probably shouldn't use another x to indicate multiply. Let's use a dot. Let's make it clear. 1.14x times what to have that additional 4%? Just like with the previous one, we don't want to multiply by 0.04 because that would be just what the 4% of it was. No, we need something that represents the 100% of the original. And my cat got on my lap, so that percent looked really wonky. There we go, 100% of the original plus an additional 4%. So we need to multiply it by 104%, or 1.04. And when I multiply those together, I am going to get, and I'm going to look at my notes because I can't multiply that in my head, I'm going to get 1.1856x. Now, so it means to get from 2007 to 2009, if I multiplied the 2007 amount by 1.1856, I would find out how much money Zina made in 2009. And what was the question? If Zina earned y times as much in 2009 as in 2007, what is the value of y? That's probably the wonkiest line I've ever drawn. What is the value of y? It is this number right here. It's what I am multiplying x by x this many times as much. It is 1.1856, which is D. Again, there's multiple ways you can look at this because of it being a percentage, but yeah, that's the way I looked at it. Number 23, circle A, shown, is defined by the equation x plus 2 squared plus y squared equals 9. Circle B, not shown, is the result of shifting circle A down 6 units and increasing the radius so that the radius of circle B is 2 times the radius of circle A. Which equation defines circle B? This is one of those equations that and problems that equation of a circle looks so complicated when you don't have the knowledge. But once you have the knowledge about how to find the equation of a circle, it's like, oh, easy peasy, and you can show off and be like, look at me with my fancy circle knowledge. So here's how it works. It is x minus h squared plus y minus k squared, I always write too big, run out of room, equals r squared. This is an equation for any circle in which the center of the circle, the center is going to be hk, so the opposite of whatever those two are, because this is, if this is positive, this will be negative. If this is negative, this will be positive. So it's the opposite of those. And then r is the radius. And that's it. So if you get a fancy equation like x minus 5 squared plus y plus 2 squared equals 16, you're going to look at it and go, all right, I know this is an equation for a circle with a center of positive 5, negative 2, and a radius, since this is r squared, I need to take the square root, a radius of 4. All circles follow this pattern. Now, some of the problems that they will give you, they don't put it in this, it's just a heads up, they don't put it in this format, and you have to put it into that format, which involves a process called completing the square. And I've never met a student yet that likes it, and I don't blame them. But yeah, I'll put a link to videos I have on completing the square down below. It's not applicable to this problem, but it is often applicable to SAT circle problems, just FYI. Now for this equation, for this circle, we're told the equation is x plus 2 squared plus y squared equals 9. And this is circle A. So just looking at this equation, I can tell I have my center and my radius. I'm just going to do it like that and not write everything out. Okay, so my center needs to be the opposite of this for the x value, so negative 2. And there isn't any number next to the y, so it's just 0, like y minus 0 squared. Now my radius is going to be the square root of this because this is radius squared. The square root of 9 is 3, so the radius of this is 3. Now they want us to write the equation for circle B. So to do that, I need to know the center of circle B and I need to know the radius of circle B. And then I can write that equation. We are told it is the result of shifting a circle A down 6 units. So the x value doesn't change. The center is just going down 6 units. So the x stays the same, but this 0 is going to go down 6 to negative 6. And it says the radius of circle B is 2 times the radius of circle A. Well, the radius of circle A was 3, so 2 times that would be 6. And now I have all the information I need to write the equation of circle B. It's going to be x, and negative 2, I'm going to put the opposite of that, plus 2 squared, plus y, again, negative 6, write the opposite, plus 6 squared is going to be equal to the radius squared. 6 squared is 36. So x plus 2 squared plus y plus 6 squared equals 36. Now that is the equation of this circle. Now, look at what they've done over here. Do you see any that say 36? No. They've chosen to write them as 4 times 9, 9, 4 times 9, and 9. It's silly. It's honestly silly. The reason they're doing this with this 4 times 9 is because this is 3, the radius is 3, and the radius squared is 9. So they're saying if it's twice that, but then you're squaring both of them, it would be this squared times this squared. 9 times 4. That's why. Ain't that silly? But, don't let it throw you. We know it's 36. So when you see 4 times 9, you go, well, 4 times 9 is 36. So I already know that these two are out, the ones that just say 9. Now let me look at those others very carefully. And I see x plus 2 for both of them. Here's the difference. One is plus 6, one is minus 6. And so we're going to very cautiously and carefully look at plus 6. A is the right one. A is my answer. Number 24. Note, figure not drawn to scale, so don't try to measure things and figure it out that way. It won't work. Right triangle ABC is shown. What is the value of tangent of A? Two things they're testing here, your knowledge of the trigonometric identities, sine, cosine, tangent, and also of 30, 60, 90 triangles. That is key for this one. If I'm not mistaken, they still do provide that. You can pull that up, 30, 60, 90 triangles, and the numbers for that. But it's always easier, faster if you have those memorized. If you forget it, don't worry about it. Use the reference. That's what it's there for. But if you can memorize it ahead of time so you know it just like that, it's going to be better and faster. Okay, so for a 30, 60, 90 triangle, which is what we have here, this is the 30, there's the 60. Man, I can't draw on a screen or write on a screen today to save my life. 30, 60, 90, and this is 54. Okay, the pattern for a 30, 60, 90 triangle goeth thusly. The side that is alongside the 60 is your x. The side that is the hypotenuse, the longest side, is 2x. And the side that's alongside the 30 is x times the square root of 3. The only way I always would remember that is the 3 and the 30, they line up. And then the others, if I remember one's x and one's 2x, well, the long one's obviously going to be twice that, right? Right. That's how my brain would work. I don't know if that helps everyone or anyone, but that helped me. So here's our pattern over here. This side is 54. That is equivalent to 2 times x. So to find x, I need to divide by 2. So half of 54, or 54 divided by 2, is 27. And now that I have my x, I can multiply it by the square root of 3, and I have that side. Now I need to know the tangent of A, and this is A up here. Tangent is equal to the length of an angle, in this case angle A. It's going to be the length of the opposite side over the length of the adjacent side. The opposite side is kind of like, if I'm sitting at a table and I'm sitting here, there's someone who's sitting opposite me, I'm looking at them. Someone who's adjacent to me, like I can bump them with my elbow. So here, angle A, the side that is opposite angle A, is the side it's looking at. And then the side that is adjacent to angle A is the one that it's bumping. And if you're wondering what the third one is called, that is the hypotenuse. It's always the longest one. It's a fancy one. The opposite and adjacent, we're talking about the legs, the two legs of the triangle. Okay, so the opposite side, the one angle A is looking at, is going to be 27 times the square root of 3. And the adjacent side, the one that's bumping elbows with, is 27. Okay, so that is 27 times the square root of 3, and then we have 27 on the bottom. We can cancel those out. It's one of those fun things we can do with fractions. So they cancel out. Boom, boom, 1, 1. And I am just left with square root of 3. So the tangent of angle A is going to be C, square root of 3. Number 25. At the time that an article was first featured on the home page of a news website, there were 40 comments on the article. An exponential model estimates that at the end of each hour after the article was first featured on the home page, the number of comments on the article had increased by 190% of the number of comments on the article at the end of the previous hour. Which of the following equations best represents this model, where C is the estimated number of comments on the article T hours after the article was first featured on the home page, and T is less than or equal to 4? Whew. Man, do they love these long, lengthy verbiage word problems where your eyes just kind of glaze over. Now, they're asking for an equation. And also when it says, which of the following equations best represents this model? A lot of times, not always, when it says best represents, it means that you need to be careful because more than one of them could apply. That's not the case on this one, but I just draw your attention to that wording, best represents. Always be on your guard, because a lot of times it'll mean there'll be like one that kind of works, but then there's one that's better, that kind of thing. Not here, just be on the lookout. But we do want to look at our equations. We could absolutely start from scratch and put together an equation for this. Totally viable if you wanted to do it that way. You could. I recommend looking at their options first because a lot of times it helps you out and, saves you some time. Why not? Even if you can do it totally on your own, which is awesome, by the way. But, even if you don't need their answers, hey, it saves you a couple of seconds. Use them. Use those answers. And what do we see when we look at these answers? We see that no matter what, it's going to be some variation of this. C equals 40 times something to the power of T, because that's what we see in all 4 of these. The only thing that changes is what we're multiplying it by. So that's our question. What are we multiplying it by? We're increasing by 190%. So I want to ask myself, how would I increase this by 190%? What would I multiply it for? What would I multiply it by? I said that totally wrong. What would I multiply it by? Look at our options here. We have 1.19, 1.9, 19, and 2.9. And I'm going to bet that a lot of you were drawn to this 1.9. It's got these 3 variations that are so close. We got 1s and 9s. It's just, little variations in where the decimal is or isn't. And then we have this outlier of 2.9. And I'm going to bet that a huge majority of the students taking this are going to be drawn to this 1.9. They're going to click on it and they're going to move on and they're going to get it wrong because this is an increase by 190%, not times 190%. What's the difference? If I said, think about it this way. If I said I had 40 comments and then after an hour it increased by 100%, would I multiply by 1? It's not changing anything, right? There's no increase at all. No, if you increase by 100%, you've doubled the number of comments. It was 40, and then there was a 100% more, 40 more that happened. So no, you don't multiply by 100 to show an 100% increase. You multiply by 100 plus 100, because that original 100, these are both percents, by the way, that original 100 represents that original number of comments. And that 100% increase is how many more comments you had. So it'd be 100 and 100, 200% if it is an 100% increase. If this were less than 100, like if this had been a, like say a 20% increase, I'd be multiplying by 120% because I need the new number to be that original number of comments plus the additional 20. So that's the 100 and the 20. So in this case, it is not multiplying by 190%. We need to multiply by 290%. So then if I do that, if I multiply that 40 by 290% or 2.9, I would be getting 100%, which is my original 40, and then the 190% increase. I'm adding those together to get 290% or 2.9. And then that t is, for every hour, you're multiplying it again by 2.9 to show in that next hour. You know, if this was to the power of 2, then you're multiplying by 2.9 times 2.9. You're doing it twice. If it was to the 3, it's 2.9, 2.9, 2.9 for each hour, that 190% increase. So I foresee a lot of students getting that one wrong. I hope I'm wrong. I hope they don't catch people with it. But it is D. C equals 40 times 2.9 to the power of t. Number 26. Given a table, and the table shows 3 values of x and their corresponding values of g of x, where g of x equals f of x over x plus 3, and f is a linear function. What is the y-intercept of the graph of y equals f of x in the xy plane? Okay, f of x is a linear function. That means it can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. Got slope and y-intercept. And if we have the slope and a couple of points, then we can figure out the y-intercept. And that's what they want. They want the y-intercept of this line. So we need to find the slope of it first, and then make sure we have a point, at least one point, and then we can solve and find the y-intercept. But how do we get this? We're not given anything, right? We're given g of x. We don't know any points for f of x, and we don't know the slope. Well, let's look at our g of x. It says that when I plug in a number x into f of x, and then I plug it through this into g of x, this is the number I get out. So let's start, setting this up. So, okay, so g of negative 27, I'm going to get 3. Well, what happened? It was f of negative 27 over x, okay, which is negative 27, plus 3. And if I do that math, I will get 3, is what that's saying. If I do g of negative 27, I'm going to get 3. Or in other words, if I put negative 27 into this over here, I'm going to get 3. Okay, so on the bottom, negative 27 plus 3 is negative 24. So to say what f of negative 27 would be, it's being divided by negative 24. Scoot it over. So I'm going to multiply both sides by negative 24 to undo that division. So I get that f of negative 27 is equal to 3 times negative 24, or negative 72. So I'm going to start this a new chart over here, x and f of x. I already have the chart for g of x. So when x is negative 27, f of x is negative 72. Now I'm going to repeat this for the other values we have in the table. Okay, so the next one says that for when x is negative 9, g of x is 0. So I'm going to plug that in here. So f of negative 9 over negative 9 plus 3 equals 0. Negative 9 plus 3 is negative 6. F of negative 9 is being divided by negative 6, so I'm going to multiply both sides by negative 6. That's times a negative, and it's not very clear. There we go. So now I know f of negative 9 equals 0 times negative 6, or 0. Okay, I've got another point. Negative 9, 0. I'm going to do all three just to show them to you. Right, our last one here says that when x is 21, g of x is 5. So, okay, again, plugging into our equation, f of 21 would be 21 plus 3, and that will equal 5. 21 plus 3 on the bottom is 24. F of 21 being divided by 24, so I need to multiply by 24 to undo that. And I get that F of 21 is equal to 5 times 24, or 120. So I've got another point, 21 and 120. Right, now I have points. I have x and y values, or x and f of x values, same difference. So I can start figuring out my equation, my slope-intercept form. Okay, so for slope, I need to do change in y over change in x. So I need to take some y values, which again would be represented by my f of x. I'm going to put that on top, and I'm going to subtract those, and then I'm going to put the x's on bottom and subtract those. I can pick any two pairs. I'm going to pick these two pairs. So my change in y, I'm going to say 120 minus 0 on top. And I started with this pair and I subtracted that pair. So I need to do the same for the x's on the bottom. So 21 minus a negative 9 on the bottom. All right. So 120 minus 0 is 120. Again, I didn't write this out, but here it is in written form. Change in y over change in x is the formula. It can also be written as y2 minus y1 over x2 minus x1. And it's just saying find an ordered pair and then subtract them. But again, make sure that this is the one ordered pair and this is the other ordered pair. It can't be that's an ordered pair and that's an ordered pair. That doesn't work. But any other ordered pairs will work in this scenario. Okay, so back to our 21 minus a negative 9 is same as plus a positive, so that is 30. So 120 divided by 30 is 4. Okay, so now I have my slope of my line. I'm going to go back up here and say f of x is equal to 4x plus b. And I can plug anything in that I want to for an x and a y value from my little chart over here. So I'm going to plug in my 0 and my 9. Okay, so plug in, or negative 9, excuse me, plug in a negative 9 for x. And I know the f of x in this case will be a 0. All right, so 0 is equal to 4 times negative 9, which is negative 36, plus b. To solve for b, I'm going to add 36 to both sides, get rid of that negative 36, and I get that 36 is equal to b. So the y-intercept for this graph, the x value is always going to be 0 for a y-intercept. It's going to be 0, 36, and that is A. Okay, erase all these over here. Number 27, last problem. In right triangle ABC, angle C is the right angle and BC equals 162. Point D on side AB is connected by a line segment with point E on side AC such that line segment DE is parallel to side BC and DE equals to AE. What is the length of line segment DE? I fully confess when I drew this, because they have all these points, all these little things, I drew it wrong when I was taking this test myself before. I always take the test, timed it, It's only fair, right? I should have to take it too. So I took it and I drew it wrong, and I'm staring at this thing and I'm like, what on earth are they wanting me to do? So always be careful. That's my public service announcement here. Always be careful when you're drawing things, when they're just describing it. And if something doesn't make sense, go back to your drawing and go, hey, maybe I drew it wrong. All right, so I have right triangle ABC. Angle C is the right angle. Okay, so ABC. Let's say A, B, C, and C is the right angle. All right, point D on side AB. Okay, so there's a point D on side AB is connected by a line segment with point E on side AC. Okay. Line E, and they're connected such that segment DE is parallel to side BC. Okay. I've drawn this now, and now I've drawn this correctly. And it says line CE is equal to 2 times AE. Well, I say correctly. I have my points all in the right place, but it is not drawn to scale, since it says that this is supposed to be twice as big as that. So if I wanted to draw one that was a little more accurate, just so you can kind of Let's see. Yeah, that's pretty good. I can't draw a straight line to save my life. There we go. I'm going to cheat and use the straight line function. All right, this one is a little more accurate. A, B, C, and I'm going to have this line here. That's D, that's E. There we go. There's a better drawing. Isn't that great? She's so proud of me I was able to draw something. Funny thing, in real life, I can actually draw. All right, computer screens are just different. All right, there we go. Got a nice setup here. And we're told that this part right here, that CE is equal to 2 times AE. So I'm going to call AE X. The length of that I'm going to call X. And CE, just this part, is 2 times that. So it is 2 times X. Okay? And we're also given one number, is that BC is equal to 162. Okay, so this 162. Now they want to know, what is the length of side DE? This is similar triangles, similar triangles, similar triangles. Boy, do they love nested similar triangles. There's another variation of the nested similar triangles. It's when they do like this, and they'll have, they'll be wanting you to know that this triangle is similar to that triangle and is similar to that triangle. I'll find some problems I've done like that, and I'll put some links down below to those problems that I've done, because that's another variation that they absolutely love, and I think is even harder to spot than this one. This one we have a similar triangle but only 2 in this particular case. Makes it a little bit easier to highlight here. We have this triangle, and we have this big triangle, and they be similar. Why are they similar? Well, if these are parallel lines and these are transversals then that are crossing these parallel lines, we could envision them going on further. Because you have these parallel lines and they're cut by this transversal, and it's 2 transversals, you got that transversal and that transversal. This angle and that angle are congruent. It has to do with those parallel line theorems you learned, talking about corresponding angles are congruent. In practice, it means these 4 angles are all congruent, and these 4 angles are all congruent. In everyday practice, not needing to do proofs, that's what you need to know. So here, this angle is congruent to this angle because we've got 2 parallel lines and a transversal, and those are going to be the same. Also, you have 2 parallel lines and a transversal here, which means this angle and this angle are parallel, are congruent. They are corresponding angles. And as soon as I have corresponding angles, I don't need a third one. If I have 2 corresponding angles, I don't need a third one. But I got it anyway, because this angle is shared by both of them. So that one is it's congruent to itself, reflexive. So I have 2 triangles that have 3 congruent angles. They are similar. As soon as things are similar, we can have a ratio set up. Now, the one catch I can see students doing is that they can get to this point, they can realize they're similar triangles, and you're like, all right, if this is 162, and this side, they said, okay, and it says that CE is twice as long as AE, so that's the proportion. Okay, everything's twice as long, so this is 162, so this is going to be 81. I'm done. No, you're not. No, you're not. Because here's the catch. This 2x and x that I showed you here, this 2x is part of this whole triangle's side, whereas this x is all of that triangle's side. See, it's the whole thing. But here, the 2x is only part of it. We need to know what the whole thing is before we can set up a ratio. So the small triangle AE is x, and the big triangle side is 2x plus x, or 3x. That's the catch. That's what they're going to get you, and that's why this is a number 27 problem. They're counting on you not to catch that. So the x's are going to cancel out, just leaving 1 and 1. So the ratio is 1 to 3, not to 2. So if I know that 1 to 3 is my ratio, and side DE is the side I don't know, and side BC, the side I do know, is 162, I can now cross multiply and I can solve for that length of the side. You can also view it as just saying, well, it's a third of it, so I can divide by 3. Same difference, both totally viable ways to look at this. So if I cross multiply, I will say 162 is equal to 3 times the length of DE. To find out the length of DE, I need to undo that, multiplying by 3. So I'm going to divide both sides by 3. And I'm going to get that DE is equal to 54. 54 is my answer. Again, it's that ratio that it's a 1 to 3 ratio because that 2x is only part of the length of this full side. That's where they're going to get you. That's why I suspect they're going to get a lot of students. But no, it is a third of this whole thing is 3x. So 54 is my answer. And congratulations, you have made it to the end. Hey guys, head over to my new site, mathwithalyssa.com, to get your free, yes, free 10-video course of SAT tips and tricks. It covers things like how to make a study plan that's perfect for you, how to pace yourself during the test to get maximum points, and so much more. I'm super excited to get this out to you guys, and a lot more SAT prep help is coming for you in the weeks ahead. Again, that is mathwithalyssa.com. And if you liked the video you just watched, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.